Alright, so we're asked in the first question of our homework to solve for the average speed. We know average speed is distance divided by time. And we're given that it goes a distance of 30 meters, or kilometers, sorry. And it takes them 2.5 hours to go that distance. We're not worried about direction here. We're simply worried about how much ground was covered in the time spent. So we're just going to plug in our values. For D, we got 30 kilometers. For T, we have 2.5 hours. We don't have to change the hours to seconds or anything like that. We can leave it kilometers per hour. And when we divide 30 by 2.5, we get 12 kilometers per hour. We don't need a direction or anything. That's all it takes to solve there. Alright, an airplane travels with a speed of 195 meters per second for 5 hours. What's the total distance traveled? Well, we know that speed equals distance divided by time. So if we want to isolate distance, we're going to divide both sides by t. So distance equals the time multiplied by the speed. But we have a problem here because our time is in hours and our speed is in meters per second. So what we want to do is we want to switch one of them to the other time unit, and it's easier here just to switch the hours to seconds. So let's do that. Let's take our 5 hours and convert that to seconds. I don't know if you remember, there's 3,600 seconds in an hour. You could go to minutes and then go for minutes and hours if you wanted. But it ends up being 18,000 seconds. So we're going to plug in our value, 18,000 seconds for t. And for speed, we're going to plug in 195 meters per second. Of course, we know seconds cancel. And we do 18,000 times 195. And we get a distance of 3,510,000 meters. But usually, we're not going to write the answer like that if it's such a big distance. Usually we probably won't write that in kilometers. I mean, you could keep this as your answer if you wanted to, but I say we divide this by 1,000, and instead of writing 3,510,000 for our answer, we write 3,510 kilometers for our answer. That would be it. You would not need a direction or anything like that because it's just distance, not displacement. All right. A car, this is number 3 if you keep following along. A car completes 1 lap around a circle with a radius of 50 meters. So here's our circle. And the radius is 50 meters. The time it takes the car to complete the lap is 1.2 minutes. What is the total distance covered? Well, we haven't talked a lot about circular motion. Well, we haven't talked any about circular motion. So if you had trouble with this one initially, I apologize. Really, when we're talking about the distance traveled around a circle, aren't we talking about the circumference of the circle? So we need to know the circumference of a circle formula, which in this case is 2 pi r. That is something that if you want to add to your formula sheet, you're welcome to, circumference of a circle. So really, we just need the radius here. 2 pi r, 50 meters for the radius. And when we multiply 2 pi r, remember pi is 3.14, we get 314.16 meters for our answer. So that one was a little tricky. I apologize for that. There's still more to the question, but as far as the distance covered is going to be, you're just going to use the circumference formula for a circle to get the answer there. So 314.16. The next question says, what is the average speed of the car in meters? Well, average speed, again, we know is distance divided by time in meters per second, so we're going to have to do some converting. We already know the distance. We solved that in the first problem, 314.16 meters. But we need seconds. So we know the time was 1.2 minutes. How are we going to convert that to seconds? So we're just going to take our dimensional analysis. We know 60 seconds in 1 minute. So 1.2 minutes times 60 seconds gives us 72 seconds. So that is going to go right there. And then our answer is going to be 314.16 divided by 72. And that ends up being 4.36 meters per second. And again, it's a speed, not a velocity. So that's our answer for the second part of number 3. All right, a family leaves from New York City and is flying to LA, which is 2,800 miles away. So we know the total distance is 2,800 miles. It takes 3.25 hours to fly from New York to O'Hare, Chicago. There they have a 1-hour layover. And then they fly to LA in 2.75 hours. What is the average speed of the travel? Well, the average speed is going to be the total distance divided by the total time. Now, of course, our distance, we already know, is 2,800 miles. And our total time is going to, of course, be T1 plus T2. Now it looks like a T. T1 plus T2 plus T3. So 2,800 miles, 3.25 plus 1 hour plus 2.75, and that gives us 2,800 miles over a total time of 7 hours. And then we're going to divide 2,800 by 7, and we get 400 miles per hour. And that is our speed for the trip. No direction because we're only solving for speed, not for velocity. Alright, a runner moves with a velocity of 3 meters per second due east. for 60 seconds. The runner then comes to rest for 30 seconds. Then turns around and heads due west at 4 meters per second. For 60 seconds. What is the total distance traveled by the runner? All right. Well, obviously we need to know our distance for the first part of the trip. Let's do that. So we're finding d1. Well, we know that velocity is total displacement divided by time. So we know that displacement's going to be velocity times time. So velocity is 3 meters per second. Time is 60 seconds. So the first distance is going to be 180 meters. Now again, it asks us for displacement. So really, I could have put a D here. Instead of X, because it asks us for distance, but it's all right if we do it that way. V2 equals X over T2. So we're going to rearrange that, solve for X, or D, if you want to call it that. So it's going to be the second velocity times the second time. So that's this part of the trip. So 4 meters per second times 60 seconds. And that's going to give us 240 meters. So we have 240. We have 180. And we're just looking for total distance. We're not talking about the direction that they ran. So we're simply going to sum those up, and that's going to give us 420 meters for our answer. That's distance traveled, not displacement. That's later on in this problem. So that's the first part of number 5. Now the next ask, what's the total displacement by the runner? Well, we've already done enough work here that it really doesn't take a long time to finish this all. We already know that he went 180 meters to the east. Or we could say positive 180 meters, because east typically is a positive direction. That was the first part of his trip. Oops. That was the first part of his displacement, going 180 meters east. Then the second part of his displacement was going 240 meters to the west. Now again, we calculated the 180 and the 240 on the previous slide. Well, west is typically a negative direction, so we could put 240 meters with a negative sign. So if I was to sum up, if I was to take my x1 and my x2 and add them together, that's going to give me the total displacement. Well, x1 is positive 180. x2 is negative 240. And this is something that we'll be doing quite a bit when we talk about vectors. Hopefully I will be there. But you always have to sum your x's and later on there'll be y's as well. Make sure that the sign's on there. So what's 180 plus a negative 240? Well, that's a negative 60 meters. So that is his displacement, or her displacement. I mean, you could use vectors as well. You could say, okay, you went this way, 180. So the vector is just an arrow pointing which way you went, to the right, how far. And you can have another vector pointing to the left, but a little farther, because 240 is farther than 180. And then the difference, whatever this value is here, from here to here, is the displacement, which would end up giving you negative 60 anyway. Your answer could also be 60 meters west. So either one is acceptable. Just remember, when you have displacement, you have to incorporate positives and negatives, east and west, north and south, that sort of thing. All right, the last question in number 5 says, what is the average velocity of the runner? So velocity equals the total displacement divided by the total change in time. Well, let's be careful here. We already know the total displacement. We just solved that. Negative 60 meters. Total time. Well, if we go back and we look at our times, we had him running for 60 seconds to the east, 60 seconds to the west. But we also had him resting. Or what did it say? It said comes to a rest for 30 seconds, so he's taking a break. Now he's not moving during this time, but this includes the time of his displacement. So when we put in our total time, we have to include that 30. So what's 60 plus 60 plus 30? Well, that gives us 150, right? 6 and 6 is 12, 12 and 3 is 15, so 150 seconds. And when we divide 60 by 150, we get 0.4. Of course, it's a negative 0.4 meters per second. Or you could have written 0.4 meters per second west. Either one of those is acceptable. But remember, total time has to be included. So the 30 seconds has to be included in there when we're talking about total displacement. All right, in the last problem, for part A, we're asked to find the average velocity from 0 to 12 seconds. So we have on our graph here an object moving from here all the way up to here in 12 seconds. So what is the formula for velocity? Well, it's total displacement divided by total time. Well, we know it was a total of 12 seconds. And what is his displacement? Well, his final position is 120, and his initial position is 0. So 120 divided by 12. And of course, that answer is going to be 10 meters per second. And they don't really give us a direction. I'm just going to say it's positive. So positive 10 meters per second is the answer to A. For B, the average displacement, well, again, average displacement, we really already did that. We did it right here. Now let's look at it. It's going to be our initial position subtracted from our final position, so 120 minus 0. Our displacement is 120 meters, positive 120 meters. So there's our answer for B. Total distance, now this is where you have to be careful. For total distance, we have to include every piece of ground covered. So from here to here, we went 40 meters. From here to here, we went 0. Now, from here to here, where did we go? We went from 40 to 20. How far is that? That's 20 more meters. Again, this is distance. I'm not worried about direction. From here to here, 0. And then from here to here would be 20 to 120. How far is it from 20 to 120? That's 100. So what's our total distance? 160 meters. So there's our answer for number, or letter C. Again, no signs there, because I'm not worried about direction. All right. When is the object not moving? Well, this is a position time graph, right? So in a position time graph, with position on the y-axis, if the position isn't moving, then the line's going to be horizontal. So right here it's horizontal, and right here it's horizontal. So when was it horizontal? Well, from 4 to 5 seconds, and from 6 to 7 seconds. It wasn't moving at all. All these other ones have slopes. So the lack of slope tells you that it is not moving. Position time graph, if you have a horizontal line, that indicates 0 movement. All right. What is the velocity of an object from 1 to 2 seconds? Well, velocity equals our displacement divided by our time. Well, from 1 to 2 seconds, that's 1 second, right? And what's our displacement from 1 to 2 seconds? Well, we go from what looks like 10 to 20. So how far is 10 to 20? That's 10 meters in a positive direction. So our speed from our velocity from 1 to 2 seconds is 10 meters per second, positive. How about from 5 to 6 seconds? Well, look carefully here. I'm going to go ahead and erase our answer to 1 to 2 seconds, so we have room. So let's get rid of that. From 5 to 6 seconds. Well, look closely. From 5 to 6 seconds, where's our initial position? Our initial position is 40. Where's our final position? Our final position is 20. So to get our displacement, isn't it going to be 20 minus 40? And how many seconds elapsed? From 5 to 6 seconds, that's 1 second. So what's 20 minus 40? That's negative 20. And then divided by 1, of course, meters per second. So there is our answer to the 5 to 6 seconds question. That's the velocity, and you would need that negative sign to be completely correct, because you got to remember that it's moving in the opposite direction. And you know that because look at the direction of the line compared to the direction of that line and this line. All right, in the last question, we are asked to solve for the velocity from 8 to 10. So 8 seconds to 10 seconds. How far did we go? Well, it looks like we went from 40 to 80. So what is our initial position? 20. What's our final position? 80. So 80 minus 20 divided by, and how many seconds elapsed from 8 to 10 seconds? 2 seconds. So 80 minus 20, that's 60. Oops. All right, correction. Where are we at 8 seconds? That's my bad. Where are we at 8 seconds? We are at 40, not 20. So this should say 40. Sorry about that. So from 8 seconds to 10 seconds, we start at 40, we go to 80. So 80 minus 40 is 20 meters divided by the elapsed time. In this case, sorry guys, that should say 40. 80 minus 40 is 40. And of course these are all positive direction or positive displacement. And divided by what? What are we doing there? 2 seconds? So 40 divided by 2 is 20 meters per second. And we would want a little plus sign to indicate up. So there's our answer to the last question, 8 to 10 seconds. Sorry for the mistakes there, but we figured them out. All right, that's all the homework problems.